Welcome, everyone, to part 3 of Service Mapping Art of the Possible series. I'm Bill Ifland, Product Success Technical Director, and I'll be your guide through this session. Today's focus is on the tag-based approach to populate and represent the MediaWiki Production Application Service. As always, I want to remind everyone about our safe harbor statement. Here's our agenda for today. Quickly review the MediaWiki CIs and which ones will be targeted, and then cover the technical and practical aspects of tag-based mapping, steps for implementing, and a live demo to show you how it all works together. Let's get started again with the MediaWiki CIs. We're focused on the production application service. Here we have 5 Linux servers that are hosting or running our application components. In a tag-based mapping scenario, we are actually getting the tags from the virtualization, the hypervisor layer of these servers. So if you have on-premise virtualization like VMware or from the cloud, we will be tagging the virtual machine instances rather than the OS. And this is by design. Again, class determines population method. Tag-based are best fit for cloud-native or container-based environments, including on-premise virtual machine environments. When thinking about tag-based application services, they too are a subclass of mapped application services, but have their own table and their own service type of tag-based. This kind of application service mapping does require the service mapping plugin. When mapping a tag-based application, we have an entry point that is the actual name, the actual record of the service itself saved as a manual CI. That is because the application service, the tag-based form, contains the metadata that instructs the service population script include how to populate the service. And that's what is meant by the top level node inside the service is the application service itself. The kinds of topologies that are built in tag-based service mapping are not quite the same as top-down topologies or those that you would see in dependency views when thinking about server to server or process to process. Rather, tag-based mapping creates stacks of technology according to your tag family definition. So what will happen with MediaWiki here is we'll have a stack that represents the load balancer, a stack that represents the Apache web servers, and a stack that represents the MySQL database. Some implementation aspects regarding tag-based application services. They're well suited for simple service membership that doesn't require process-to-process connection or process-to-process topologies. Also, they are best suited for cloud and containerized deployed services. They're built automatically using discovered tag attributes from our devices when they're provisioned, as well as CI tag categories and the grouping of those categories into service families. Once these definitions are established, the service map is built automatically and kept up to date. Some considerations when dealing with tag-based application services. It does require a well-defined and a maintained tagging strategy. Removing tag categories should not be done without careful consideration, as this will break any tag families that are using them. Likewise, tag-based service family grouping should not be reordered without careful consideration. If you require a different order, it is best practice to rebuild a new service family with the desired order. Also, tag-based service traversal rules will help add the topology relationships. These come from either service graph connectors or IP-based discovery. In my demo, I am depending on IP-based discovery to give me additional relationship data that the traversal rules will find and add to the map. So let's look at the steps to produce these kind of service maps. First, we need cloud and IP-based discovery to give us the richest, deepest service maps. From cloud or the VMware environment, we would need the tags themselves, aka the key values, the name value pairs. And for the traversal rules to further build out the map, some form of server discovery. So once we collect our tag values, we need to get an understanding of them. And with that understanding, then we can build out tag categories that are most meaningful. Tag categories like application, environment, location, cost center, owner. And once you build your tag categories, you bundle them in tag-based families. For example, application by environment or application by location if you have multiple data centers. From the tag-based families, map candidates are created. And it's from here that you select the ones that you desire. Lastly, tag-based travel rules then add to the service map, pulling data from the CMDB rel CI, the CI relationships table, also known as non-tagged CIs. Now let's move to the live demo in my IFI instance. Here I pulled up in the service operations workspace our initial tag-based service map. Here, notice that each of these CIs that are on the map currently are of the type virtual machine instance. That is because they are the tagged-based ones. And for our exercise, I have turned off the traversal rules so I can demonstrate them one at a time. But before we do that, let's quickly review the tag-based application service record. Like manual, there are three ways that you can actually look at a tag-based application service record. First is from the form view on the table itself, CMDB CI service by tags. Notice it's a little different than the manual map. We have a new set of fields telling us about the service family and the metadata that was used to capture the service. It also uses manual endpoints to connect the service and its CIs. We can also look at it from the service mapping UI and notice it is also manually created. It has a manual CI added, which is the service itself, but everything here is read-only. The only thing you can really manage from this UI is the additional info. And notice we have the category values that were defined by the service family. The third way to look at these is through the CSDM Managed Technical Services. On this first page, of course, is the CSDM relationships. And then the second tab, you pick the method for populating. Notice once you've started a tag-based service, you cannot add any other CI types or methods. If we break it down, we see the same service family and the criteria that was used to create this and the values that ended up building this application service. So let's walk through those steps. Quickly looking at our CMDB key values, we can analyze the data for the tags that will give us the outcome we desire. Here, I know that in our lab, we use application as a key to identify the machine instance that belongs to an application. Likewise, we assign environments to the same virtual machine instances. Not every CI key, or excuse me, not every record in the CMDB key values table will be beneficial or helpful. So just focus on the ones that will give you the outcome that you desire. Sometimes you'll have typos, sometimes you'll have variations on the same concept. And when that occurs, you use the CI tag categories to help normalize. So these are the two that we're going to focus on, and we're going to normalize these key values. So under the CI tag category table, this is where we would build our various category names. You can continue to add to this table without any impact. And you can also continue to add here the tag values that may arise from the new discoveries. Here, I've put key that we usually use and also anticipating variations. Similarly, I've done for the environment. And now that I've defined my tag categories, I'm ready to collect them together in tag families. So to do that, I went to the tag-based family menu, clicked the new button, and then added my various keys. Once you've established your keys, consider them to be immutable. This order, as I mentioned earlier, should be maintained. If you rather add a new key or reorder this, my recommendation would be to build a new service family. Once you've defined your tag categories, it is now time to create your candidates. Candidates are refreshed every night with a scheduled job, but you can also update them on demand. Once you've created your candidate list, you can see them here. Any candidate that has been mapped will be added to the map services related list. To map a candidate, simply select it and click Map Selected. And it will be added to the related list below. Once it's been related, you can rename it to anything you desire as long as it is unique. So let's further investigate our production application service. Here, we notice again that these are just virtual machine instances. I have run horizontal discovery in my environment to find the operating systems that are virtualized by these virtual machines. And I would like to add them to my service map. For the sake of my demo, I turned them off so that we can highlight how this process works. If I look at the tagged CIs, only the virtual machine CIs are tagged. List CIs show me all the CIs that have been found along with the tagged configuration items. To emphasize again, manual endpoints are used to connect the configuration items on a tag-based map. Now let's look at the traversal rules. For the sake of my demo, I have turned off several of them so that I can demonstrate their power. Recall that only the virtual machine instances are tagged. So let's go ahead and activate a couple of the traversal rules to build out our stacks. Let's first add the name of our vCenter data center to our service map, as well as the OSs that are instantiated from the virtual machines. To get the service updated before the next scheduled run, we can recalculate it. Before looking at the map itself, let's revisit the CIs. And now we can see that we have Linux servers that are instantiated with our virtual machines and our data center. So let's look at how that rendered. Our original tagged CIs are this layer. The CIs that were built from traversal rules are the vCenter data center and the 5 Linux servers that are instantiated. This is only possible when combining the vCenter probe or cloud discovery with IP-based discovery that built and brought in these servers into the CMDB. Lastly, let's add the applications that are running on each of those Linux servers. Go back and recalculate. Let's look at the list CIs again to show all the class and all the CIs that were added to the map. Now we have the tracked configuration data as well as the applications that were running on the servers. And this is one of those considerations that you need to understand when building tag-based maps. Sometimes it will bring in additional CIs purely by the relationship, but without any context. So I have a Unix printing system CIs and KVM applications in addition to the desired ones of Apache, HA proxy, or the SQL Server database. So let's look at the map. And we'll notice that we have our technology stacks, as I mentioned earlier. I have the stack that represents my Apache servers. Then I have a stack that represents my MySQL server. And I have a separate stack that represents the load balancer. Yes, it's true that all of these CIs comprise of my service, but it's not showing me the process to process relationship. So that's another consideration when looking at tag-based application services. The list CIs that I was showing you here on the record, that data is coming from the Service CI Association. And so when we started, we simply had the virtual machines tagged. Then by traversal rules, we're going to be able to add more CIs that aren't tagged to the service. And let's refresh this list so we can see we went from 13 unique CIs to over 70. So we went from just virtual machines to full application stacks. This concludes this session. Thank you for joining me today. See you soon in part 4.